Hello everyone, welcome back. So, we were discussing about binomial theorem. We have discussed how the expression of a binomial theorem is written. So, what we are going to do today is we are going to reinvigorate our learning by doing some worked out problems. So, let us begin. This is the first question. So, here we need to expand the binomial expression x squared plus 2a, which is raised to the power of 5, using the binomial theorem. So, let us begin. So we have x squared plus twice of a raised to the power of 5. So we'll use the binomial theorem. The first term would be 5c0 x squared raised to the power of 5 minus 0, which is 5. Then twice a raised to the power of 0 plus 5c1 x squared raised to the power of 5 minus 1, which is 4, times a squared twice a raised to the power of 1 plus 5c2 x squared raised to the power of 5 minus 2, which is 3, times twice of a raised to the power of 2 plus 5c3 x squared raised to the power of 5 minus 3, which is 2, times the twice a raised to the power of 3. So that's the fourth term. Then we come to the fifth term, which is 5c4 x squared raised to the power of 1. 5 minus 4 is 1, and times twice of a raised to the power of 4. And the final term, which is the sixth term. And if you remember from the previous class, the number of terms is can be found by using the formula n plus 1, where n is the index. Since we have n equals to 5 here, so 5 plus 1 is 6, and that's what we're getting. 1, 2, 3, 4, 5, 6. So 5c5 will be the sixth term. So 5c5 x squared raised to the power of 0 times twice of a raised to the power of 5. Okay, now we need to determine the coefficients and simplify all the expression. So 5c0, you can plug this value into your calculator, or you can always use the formula for NCR, and that would give you 1. So the first value is 1, x squared to raised to the power of 5. So this will be simply 2 times 5, which is 10, times twice of a raised to the power of 0. It's always 1. So we have the first term. Then we move on to the second term. So 5c1. So 5c1 is 5. You can verify it. Times x squared raised to the power of 4. So 2 times 4 is 8. X raised to the power of 8 times twice of a plus 5c2. So 5c2 is it's 10. It is 10. You can check it out. So we have it's 10 times x raised to the power of 6 times twice of a squared, so that will be 4a squared, plus 5c3. Now 5c3 is also 10. 10 times x raised to the power of 4 times twice of a whole cube will give us 8a cubed, plus 5c4. So 5c4 is 1. 5c4 is 5. My bad. So 5c4 x squared times twice of a raised to the power of 4. So that would give us 16a raised to the power of 4 plus 5c5, which is 1. X squared raised to the power of 0 is 1. And twice of a raised to the power of 5 would be 32e raised to the power of 5. Okay. So the final step is to simplify. So this will be x raised to the power of 10, the first term. Then 5 times 2 is 10. So this is 10a x raised to the power of 8 plus 10 times 4 is 40. So this is 40 a squared x raised to the power of 6 plus 10 times 8 is 80. 80 a cube x raised to the power of 4 plus 16 times 5 is also 80. 80 a raised to the power of 4 x squared plus final one is 32 and a raised to the power of 5. So yeah, this is it. So this is the binomial expansion of x squared plus 2a whole raised to the power of 5. Okay, let's do another problem. Second question. So in the second question, we have the expression twice x minus thrice y raised to the power of 4, and we need to expand it using the binomial theorem. So let's write down all the terms. Twice x minus thrice of y raised to the power of 4 is equals to 4c0 twice x raised to the power of 4 times negative thrice of y raised to the power of 0. So what we have done here, if you are to compare with our original equation, x plus a raised to the power of n, so here we are taking twice of x equivalent to x, and a is equivalent to negative thrice of y. Let's go to the second term. So this is 4c1 twice x raised to the power of 3 negative 3y raised to the power of 1. Then we have the third term, which is 4c2 twice x raised to the power of 4 minus 2 is 2 times negative 3y raised to the power of 2 plus 4c3 twice of x raised to the power of 1 times negative thrice of y raised to the power of 3 plus the final term, which is the fifth term, 4c4 twice x raised to the power of 0 times negative 3y raised to the power of 4. Okay, so 4c4 is 1, twice x raised to the power of 4 is 16, x raised to the power of 4, and negative thrice of y raised to the power of 0 is 1. Plus 4c1 is 4, so twice of x whole cube would give us 8x cubed times, so this is 1, looked like over 2 to me. So this is 1, so this is simply negative thrice of y plus 4c2. So what is 4c2? Let me quickly calculate. 4c2 is equals to 4 factorial divided by 2 factorial times 2 factorial, which is equals to 4 times 3 times 2 factorial divided by 2 times 2 factorial. So instead of writing 2 factorial, one of the 2 factorial, I'm simply writing as 2. This 2 and 2 factors are 4 times 3 is 12, 12 over 2 is 6. Okay, so this is 6. Twice of x squared is 4x squared times negative 3y squared is 9y squared plus 4c3. So 4c3 is 4 times twice of x, and times negative 3y cubed will be 27y cubed plus 4c4, which is 1, twice x raised to the power 0 is 1, and negative 3 twice of y raised to the power 4 is 81y raised to the power 4. So this should give us the final result as 16x raised to the power 4 negative. So 4 times 8 is 32, 32 times 3 is 96, 96 x cubed y plus, I have to use a calculator, 6 times 4 plus 9. So 6 times 4 is 24, 24 times 9 is 216, 116 x squared, y squared, negative 4 times 2 is 8, 8 times 27 is 216. Great. 216 xy cubed plus 81 y raised to the power 4. Okay, so this is the expression. This expression gives you the expansion of twice x minus thrice y raised to the power of 4. Here, we did talk about this one particular thing in the conclusion. Let me quickly review. If you Look at the first term. Look at the first term, the index of x is 4, which is equivalent to the original index n equals to 4. When we look at the second term, the index of x is 3, while the index of y is 1. And when you add them, 3 plus 1, you get 4, which is exactly equals to the original index 4. Similarly, you can go to the third term. The index of x and y are both 2. When you add them up, you get 4. Same goes for the fourth term and for the final term. Okay, let's move on to the next question. Okay, the third question. If you remember from lecture number 1, I left this one as an exercise. So we're going to do this. So we have to expand 1 plus x squared whole raised to the power 3 using binomial theorem. Now here you can notice this expression 1 plus x squared is not binomial. It's a trinomial because it has 3 terms, 1x and x squared. So how do we do it? So what we're going to do, so we're going to simply substitute x plus x squared. It's a variable, let's call it t. So our expression would look something like 1 plus t whole cube. Now this is way easier to solve. Now this has got converted into a binomial expression, 1 plus t. Now let us expand it. So this would give us 3c0, 1 raised to the power of 3, which is always 1, t raised to the power of 0, plus 3c1, 1 raised to the power 2 is always 1, so I'm skipping it for now, plus t to the power of 1, plus 3c2, that is t squared, plus 3c3 t cubed. So 3c0 is always 1, t raised to the power 0 is always 1, so this will give us 1. 3c1 is 3, so this will be 3t, thrice of t. 3c2, so what's 3c2? 3 factorial over 2 factorial over 1 factorial, so this is 3. So this is 3 t squared, and 3c3 is 1 t cubed. Anyways, we didn't have to use binomial theorem because we know 1 plus t cubed is equivalent to 1 plus 3t plus 3t squared plus t cubed, which you can use it. You could have used it as an identity, but since we're doing binomial theorem, so I wanted to show you how it's done. Okay. Now this is done, what we're going to do is replace the t by x plus x squared. So we have 1 plus 3 instead of t. Now we're going to replace it by the original expression, which is x plus x squared, plus 3x plus x squared whole raised to the power of 2 plus t cubed, which is x plus x squared raised to the power of 3. Now you can see the first, second and third term are very easy to expand. So what we're going to do, we're simply going to expand it using a normal distribution and normal arithmetic, while we're going to reapply the binomial theorem on the fourth term. Okay, so let me rewrite it. So this becomes 1 plus thrice of x plus thrice of x squared plus 3 times, so this is a plus b whole squared, so this will become x squared plus, so 2 times x squared is 2x cubed, plus x squared raised to the power of 2 will give us x4. That's it. Now what we're going to do is we're going to apply x plus x squared raised to the power of 3. Here we're going to apply the binomial theorem. So this is 3c0 x raised to the power of 3 times x squared raised to the power of 0, which is 1, so I'm not writing it right now. Then we have 3c1 x cubed x raised to the power 2 times x squared plus, I hope there's enough space, 3c2 x raised to the power of 1 x squared raised to the power of 2, and the final term, which is 3c3 x raised to the power of 0 times x squared raised to the power of 3. So far so good. Okay, rewriting all the previous terms, we have 1 plus thrice x plus 3x squared plus, now we're going to distribute the 3. So this would give us 3x squared plus 3 times 3 is 6, 6x cubed plus 3x raised to the power of 4 plus 3c0, which is always 1, so this would give us x cubed plus 3c1 is 3, and x squared times x squared would give us x raised to the power of 4 plus 3c2 is also 3, x times x raised to the power of 4 would give us x raised to the power of 5, 3c3 is 1, x raised to the power of 0 is 1, so we're left with only x squared raised to the power of 3, which is x raised to the power of 6. Great. Now we're going to combine all the like terms, so starting with 1, this unlike terms, no constant, so 1 will stay as it is, thrice x. Any x terms? No, this is the only one, so 1 plus thrice x plus x squared term. Yes, we do have 2 x squared terms, so this adds up to give us 6x squared. Then x cube, okay, we have 2x cubed, so 6 and 1, so that would give us 7x cubed. Then moving on to the 4x raised to the power of 4, so 1 and 2, so this would give us 6x raised to the power of 4 plus fifth power of x, there's only 1, I can't see anything else. Okay, 3x raised to the power of 5, and the final one is x raised to the power of 6. I think everything has been taken care of, so we have the final expression as 1 plus thrice x plus 6x squared plus 7x cubed plus 6x raised to the power of 4 plus 3x raised to the power of 5 plus x raised to the power of 6. So this is the binomial expansion of 1 plus x squared whole raised to the power of 3. So what we did, so we were given a trinomial expression, so what we did, we tried to convert it to the familiar binomial expression by letting x plus x squared equals to t and following the steps as we just did. Okay, moving on to the next question. So this is the fourth question, 1 minus x plus x squared raised to the power of 4. So this is similar along the lines of the previous question, so let's do it. So here what we're going to do, so 1 again, it's the same thing, 1 plus x squared. This is a trinomial expression, so we need to make it somewhat similar to a binomial expression. So what we're going to do, we're going to let negative x plus x squared equals to, let's take a different variable this time, let's take a. Okay, so this becomes 1 plus a raised to the power of 4. So this, using the binomial term, we'll get 4c0, 1 raised to the power of 4 is 1, so skipping it, so we'll have a raised to the power of 0 plus 4c1, so you can skip the 1, so that's the benefit of having a 1 is the first term, so you can always skip the first one. So a raised to the power 1 plus 4c2, a squared plus 4c3, a cubed plus 4c4, a raised to the power of 4. Then 4c0 is 1, a raised to the power 0, the first term is 1. 4c1 is 4, this is 4 of a. 4c2, let me quickly find out the value of 4c2, 6. 4c2 is 6, 6a squared. Then 4c3 is 4, 4a cubed plus 4c4 is 1, so where we left it, raised to the power of 4. Then what we do is replace a by the original value, which is negative x plus x squared plus 6 times of a squared, which is negative x plus x squared whole squared plus 4 times negative x plus x squared whole cube plus negative x plus x squared whole raised to the power of 4. Okay, so now what I'm going to do, I'm not going to apply the binomial theorem to the fourth term, that's the cubic power. So what I'm going to do is I'm going to simply use the formula. So I'm going to use the identity a plus b. I am going to use the identity a plus b whole cube is a cube plus thrice a squared of b plus thrice ab squared plus b cube, so that I can work on the fifth term, which is negative x plus x squared raised to the power 4. This I'm going to expand using the binomial theorem. Okay, let's do it. So we have 1. So we're going to distribute 4. So we're going to negative 4x plus 4x squared plus 6 times. So we're going to use the identity a plus b whole squared. So this would give us x squared minus 2x times x squared is x cubed plus x squared whole squared is x raised to the power 4. Right. Plus 4 times, this is going to be negative x cubed, which is negative x cubed, plus 3 times, so this is going to give us plus 3 times x raised to the power of 4. Doing it correct? Yes, this is correct. Minus 3 times x4, so this is 3x raised to the power of 5 plus x raised to the power of 6. Then we come back to the binomial expansion of negative x plus x squared raised to the power of 4. So this is 4c0 negative x raised to the power of 4 and x squared raised to the power of 0 plus 4c1 negative x raised to the power of 3 x squared raised to the power of 1 plus 4c2 negative x raised to the power of 2 times x squared raised to the power of 2 plus 4c3 negative x raised to the power of 1 times x squared raised to the power of 3 plus 4c4 negative x raised to the power of 0 times x squared raised to the power of 4. So finally you'll get 1 times negative 4x plus 4x squared plus 6 times x squared minus 12x cubed plus 6x raised to the power of 4 minus 4x cubed plus 12x raised to the power of 4 negative 12x raised to the power of 5 plus 4x raised to the power of 6. Then we come to the binomial one. So 4c1 is 1. Negative x raised to the power would simply give us x raised to the power of 4 plus 4 times, this would be negative. So this is 4x raised to the power of, so x cubed and x squared would give us x to the power of 5. Then we have 4c2, so 4c2 is 6. So we have 6 negative x squared and x raised to the power 4, so that would give us x to the power of 6. Then negative 4c3 is 4, so 4x times x raised to the power of 6, so that is 4x raised to the power of 7 plus 1, so this is x raised to the power of 8. Now let's combine all the like terms. So let me begin by writing the highest power of x, so which is x raised to the power of 8. This is done. Then we go to the next lowest power of x. Right after x to the power 8 is x to the power 7, so there is only a single term, so this is negative 4 x to the power of 7. Then we have x to the power of 6. Are there any terms? Yes, there's one more term, one here. 6 and 4 gives us 10. So this is 10x raised to the power of 6. Then we have negative 4 and new more and negative 12. So this would give us negative 17x raised to the power of 5. And for 4 we have 1, so this is 12, so this is 13. 13 and 6 is 19. Okay, so we have 19x raised to the power of 4. And we go to the x cubed one. So x cubed is negative 4x cubed and positive 6x. No, not this one. So we have only this. Why is there no x cubed here? Am I missing something? Okay, so this is the one. Sorry, this was right in front of me. So this is 16x cubed. Then we have x squared. So x squared is 6x squared. 4x squared, this is 10x squared. Then x squared. Okay, great. Nothing else. So this is 10x squared. And x. So we have negative 4x. Anything else? No. So that's the only term, negative 4x plus 1. So this is the binomial expansion of 1 minus x plus x squared raised to the power of 4. That was a long one. Okay, so the binomial expansion of 1 minus x plus x squared raised to the power of 4. Great. Now the next one. We have to expand 1 plus x over 2 minus 2 over x whole raised to the power of 4. Here, x cannot be 0 by using the binomial theorem. Okay, let us begin. So, let's rewrite the expression as, let's rewrite it as 1 plus x by 2 minus 2 by x whole thing raised to the power of 4, and we are going to expand it. So this is simply 4c0. Now, as I mentioned in the previous question, the benefit of having a 1 as the first term is we do not have to write it. So we only focused on the second term, which is x over 2 minus 2 over x raised to the power of 0 plus 4c1 x over 2 minus 2 over x whole raised to the power of 1 plus 4c2 x over 2 minus 2 over x squared plus 4c3 x over 2 minus 2 over x raised to the power of 3, and the final term, which is 4c4 x over 2 minus 2 over x all raised to the power of 4. So let's take care of the coefficients. So 4c0 is 1, x over 2 minus 2 over x raised to the power 0 is 1. The first term is always going to be 1 for this particular case. 4c1 is 4 times x over 2 minus 2 over x plus 4c2 is 6 x over 2. So let's straight away expand it. This one is a simple one, so we'll get x squared over 4 minus 2 times x over 2 times 2 over x plus 2 over x whole square is 4 over x squared. Same thing we can do. 4c3 is 4. So we'll use the identity here, x over 2 whole cube, it is x cubed over 8 minus 3 times a squared. So this is x squared over 4 times 2 over x plus 3 times x over 2 times 2 over x whole squared, so it is 4 over x squared minus twice of 2 over x whole cube, so that would give us 8 over x cubed. Okay, now we have to expand 4c4 is 1, so take care of the coefficient. X over 2 minus 2 over x raised to the power of 4. We again have to expand it using the binomial theorem. So this is 4c0 x over 2 raised to the power of 4 times negative 2 over x raised to the power of 0 plus 4c1 x over 2 raised to the power of 3 times negative 2 over x raised to the power of 1 plus 4c2 x over 2 raised to the power of 2 times negative 2 over x raised to the power of 2 plus 4c3 x over 2 raised to the power of 1 times negative 2 over x raised to the power of 3, and the final term 4c4 x over 2 raised to the power of 0 times negative 2 over x raised to the power of 4. That was very lengthy. So we'll have 1 plus, so 4 times x over 2 is twice x, 4 times 2 over x is 8 over x, plus 6 times x squared over 4 is 3x squared over 2, minus, so this x by 2 and 2 by x gets factored out, so we're only left with 2, so 6 times 2 is negative 12, plus 6 times 4 is 24, 24x squared, plus 4 times x cubed over 8 is going to give us x cubed over 2, minus, let's multiply, 4 times 3 is 12, 12 times 2 is 24, 24 over 4 it's 6, so this is 6, and we have x cubed over x, so one of the x's get factored out, we are left with 6x, plus, so 4 times 3 is 12, 12 times 4 is 48, 48 over 2 is 24. So this is 24, so there's an x squared term in the denominator and one x in the numerator, so they get factored out, we're left with x in the denominator. So it's 24 over x minus of 4 times 8 is 32, so 32 over x cubed. Okay, then we come to the next term, so 4c0 is 1, x over 2 raised to the power of 4 is x raised to the power of 4, 2 raised to the power of 4 is 16, and negative 2 over x raised to the power of 0 is 1. Okay, the next term would be 4c1, which is 4 times x cubed over 2, x cubed over 8, this is x cubed over 8, times 2 over x, plus 4c2 is 6, 6 times x squared over 4 times 4 over x squared, plus 4c3 is 4, so this is simply x over 2 times negative 2 cubed is 8 x cubed, plus 4c4 is 1, x over 2 raised to the power 0 is also 1, so negative 2 raised to the power 4 is 16 divided by x raised to the power 4. So the last step, okay, there's one more step, we have to combine the like terms, but before that we're going to simplify. So this is 1 twice x minus 8 over x plus 3 x squared over 2 minus of 12 plus 24 over x squared plus x cubed over 2 minus 6x plus 24 over x minus 32 over x cubed plus x raised to the power 14 over 16. So 4 times negative 2 is negative 8, negative 8 over 8 is 1, x, one of the x's get factored out, so we'll be left with minus x squared plus 6 times 4 is 24, 24 over 4 is 6, so x squared, so we're left with only 6 plus 6 for this term. Then we have negative 4 times 8 is 32, 32 over 2 is 16, so 16 x squared, so we have an x in the numerator and a cubic x in the denominator, so they factor out, leaving behind x squared in the denominator, plus 16 x raised to the power of 4. Okay, the final step, we're going to combine all the like terms. So there's a constant here, so plus 6, and plus 6 is going to give us 7. Let's see, should have been negative 6. Did I make any mistake here? 6. Oh, no, it's fine. It's fine. There's a 12 here, so 1, negative 12, and 6. So that should give us. That would give us negative 5. That's done. So let me mark it. Negative 1, positive 1, negative 12, and 6. So that's done. Then we go to the x one. So twice x and negative 6x. This would give us negative 4x. Then we go to the x squared term. X squared is twice x squared over 2. Anywhere else? So there's another x squared here. So twice x squared over 2 minus x squared would give us x squared over 2. Then we go to the cubic, x cubed over 2. Another one. No, we don't have. So that's the only one. So this is x cubed over 2. Then x raised to the power of 4. So that's also a single term. So this is x raised to the power of 4 over 16. We mark it. Any x to the power 5 term? No. Then we come back to over x. So negative 8 over x. And positive 24 over x. So that is 16 over x. So 16 over x. Then we have 24 over x squared, negative x, and 16x squared. So that would give us plus of 8 over x squared. Then we have negative 32 over x cubed. Okay, only one term, so this is negative 32 over x cubed. And the final one is 16 over x raised to the power of 4. So the fourth power of x. Okay, so this is the final answer. So this is the expansion of 1 plus x over 2 minus 2 over x whole raised to the power of 4. Very lengthy answer, very lengthy steps were involved, but nonetheless, this is how it's done. So here we go. So this is the final value for the expansion of the given binomial expression. Okay, I think we have a pretty good hold over the problems right now. So let's do a few more problems. Okay, so what we have to do is we have to find the expansion of thrice this is thrice x squared minus 2ax plus 3a squared to the power 3 using the binomial theorem. What I'm going to do is I'm going to consider the first two terms as a single unit. Twice ax plus 3a squared all raised to the power of 3. Okay, so now we apply the binomial theorem. So this is 3c0 thrice x squared minus 2ax whole raised to the power of 3 times 1 plus 3c1 thrice x squared minus of 2ax raised to the power of 2 times thrice of a squared raised to the power of 1 plus 3c2 thrice x squared minus 2 of ax raised to the power of 1 times thrice a squared whole square. And the final term is 3c3. So this is 1. This is 3x squared minus 2x raised to the power of 0 times thrice a squared raised to the power of 3. Okay, so let's find the coefficient quickly. So 3c0 is 1, so we have thrice x squared minus of 2ax raised to the power of 3 plus 3c1 is 3, and this 3 multiplied with thrice of a squared should give us 9a squared times thrice of x squared minus of 2ax whole squared plus 3c2 is also 3, so 3 times 3a squared whole squared, so that's 9a raised to the power of 4, so 9 times 3 is 27, so this is 27a raised to the power of 4 times thrice x squared minus of 2ax, and 3c3 is 1, so 3a squared whole cube is 27a raised to the power of 6. Great. Now we're going to expand. Now we are going to expand 3x squared minus 2x whole cube, again by using the binomial theorem. So this is 3c0 thrice x squared to the power of 3. So negative 2ax raised to the power of 0 is 1. So I'm rewriting it. 3c1 is 3x squared raised to the power of 2 times negative 2ax plus 3c2 3x squared times negative twice of ax whole squared plus 3c0, 3c3, so thrice x squared raised to the power of 0 is 1, so skipping that one as well, so negative 2a raised to the power of 3, great, plus 9a squared. So I'm going to use the identity a minus b whole squared. So thrice x squared minus 2ax whole squared would be 9x to the power of 4 minus 2 times thrice x squared is 6x squared. So 6x squared times 2a is 12 ax cubed plus 2ax whole squared, which is 4a squared x squared. Now we're going to distribute 27a raised to the power 4, so this would give us 81 a4x squared minus 54 a5 e to the power 5 times x plus 27 a to the power of 6. Okay, so this we're done. 3c0 is 1, 3x squared whole cube is 27x to the power of 6 plus 3c1 is 3, so this is 3, let me rewrite it, 3x squared is 9x to the power of 4 times 2ax plus 3c2 is 3 times 3x squared times 4a squared x squared plus 3c3 is 1, so this is negative 8a cubed plus, okay, so 9a squared, 9 times 9 is 81, 81a squared x to the power of 4 minus 9 times 12 is 108 a cubed x cubed plus 9 times 4 is 36, so a squared which gives us a to the power of 4 x squared, and the rest of the terms 81 a squared x 81 a4 x squared minus 54 a4 x plus 27 a to the power of 6. Okay, so we're done. And finally we're going to add, there's one more thing that we need to do. So this is 27 x to the power of 6 negative 9 times 3 is 27, this is 54, so this is 54 a x to the power of 5 plus 3 9 times 4 is 36. 36 a squared x to the power of 4. Then we have negative 8 a cubed plus 81 a squared x to the power of 4 minus 108 a cubed x cubed plus 36 a to the power 4 x squared plus 81 a to the power 4 x squared minus 54 a to the power 5 plus 27 a to the power of 6. That was very lengthy. Then we have finally 27x to the power of 6. And x to the power 5 terms, only a single one. So this is minus 54 ax to the power of 5. Then we go to a square x to the power of 4. A squared and a squared terms. I think I'm missing something. So let me quickly recheck. 27x to the power 6 minus 44x to the power 5 plus 36x4 a squared plus 81 a squared x4 minus 108x cube a cubed plus 36x square a4 plus 81 x square a4 minus 54 a5x plus 27 a to the power of a6 minus 54. Yeah, everything is fine. Fine. So we have that a square x4. So we have 117. Okay, so we have 117 a squared x to the power of 4. Then we need a cube x cubed. So we have negative 108 a cube x cubed. Any more left? A cube x cubed. None that I can see of. So this is negative 108 a cubed x cubed. Then with a4 x6, so that's a4 x is 36. So this is again 117. So 117 a4 and x6 x squared. Sorry, a4 and x squared. And we need a5 and x, a5 and x. So this one here, e to the power of 5. Anything else? No. So this is minus 54 e to the power of 5 over x. And what are we left with? We're left with 27 a to the power of 6. So here, so this doesn't fit into the term. Why? Because remember, when you add the exponents of x and a, that should give you 6. That should give us 6, which is equivalent to n. So something is missing here. 8. So this is our fourth term. So this is negative 8a cubed. Negative 8a cubed. This was our fourth term. Oh yes. So this is the mistake that I have done here. So this is 2ax cubed. So 2ax cubed is a cube x cubed. A cube x cubed. So this is x cubed. A cube x cubed. So this one gets added to this one. So and then we should get not negative 108 but negative 116. Makes sense. Have we left anything behind? No, everything is great. So this is the final answer for the expansion of, what was the question? This is the one. Thrice x squared minus 2ax thrice, write the question, thrice x squared minus of 2ax plus thrice a squared whole raised to the power of 3. So this is the binomial expansion. Okay, so I think we are very much on the good track right now. Let's do a little bit simple this time. It has taken so much of time writing these terms. Okay, let's go to the next question. So we have x plus 1 over y raised to the power of 11. So we need to expand it. Let's do it slowly and steadily. So this is 11c0 x to the power of 11 times 1 plus 11c1 x to the power 10 times 1 over y plus 11c2 x to the power of 9 times y squared plus 11c3 x raised to the power of 8 1 over y cube plus 11c4 x raised to the power of 7 times 1 raised to the power of 4 plus 11c5 x to the power of 6 times 1 over y raised to the power of 5 plus 11c6 x raised to the power of 5 times 1 by y raised to the power of 6 plus 11c7 x raised to the power of 4 times 1 over y raised to the power of 7 plus 11c8 x raised to the power of 3 times 1 over y raised to the power of 8 plus 11c9 x raised to the power of 2 times 1 over y raised to the power of 9 plus 11c10 x raised to the power of 1 times y raised to the power of 10, and the final one is 11c11 x raised to the power of 0 is 1, so I'm not writing it, 1 over y raised to the power of 11. Okay, so let us use a calculator to quickly find out the coefficients. So this is 11c0 is always 1, so the first term will be x raised to the power 11 plus 11c1, so 11c1 is 11 times x raised to the power of 10 over y. Then we have 11c2. Okay, use my calculator. 11c2 is 55. So this is 55 x raised to the power 9 over y squared plus 11c3. So 11c3 is 165. So 165 x raised to the power of 8 over y cube. Then 11c4 is 330 x raised to the power of 7 over y raised to the power of 4 plus 11c5. So 11c5 is 462 x raised to the power of 6 over y raised to the power of 5 plus 11c6. This is also 462 x raised to the power of 5 over y raised to the power of 6. Then we need to find 11c7. So 11c7 is 330 x raised to the power of 4 over y raised to the power of 7. Then this was 11c7, so 11c8 would be 165 x raised to the power of 3 divided by y raised to the power of 8 plus 11c9. 11c9 is going to be 55. 11c9 is 55, so we have x squared over y raised to the power of 9 plus 11, which is 11c10. 11 times x over y raised to the power of 10. 11c11 is 1 plus 1 over y raised to the power 11. So this is the binomial expansion of x plus 1 over y raised to the power of 11. That's the answer. Okay. Now let us move on to the next question. Next question is very interesting one. This was covered in lecture number 3. So the question goes something like this. So we have x plus y raised to the power of 5 plus x minus y raised to the power of 5. So we have to expand this binomial expression, and then using whatever the result we get, and using that we need to find, and then we need to find the value of root 2 plus 1 raised to the power of 5 plus of root 2 minus 1 raised to the power of 5. Okay, so if you remember, there's a very simple one, x plus y raised to the power of 5. We've talked about it, x plus y raised to the power of 5 plus x minus y raised to the power of 5. So this is 2 times 5c0 x to the power of 5 y to the power of 0 plus 5c2 x cubed y squared plus 5c4 x times y raised to the power of 4. So let's solve it. So this would give us 2 times 5c0 is 1. So we have x to the power of 5. 5c2, so 5c2 is 10. So this is 10x cubed y squared plus 5c4 is 1. So this would give us xy to the power of 4. Okay, so this is the simplified version. Now what we're going to do, we're going to replace, or we're going to substitute x by root 2 and y by 1. So this expression would look something like root 2 plus 1 whole raised to the power of 5 plus root 2 minus 1 whole raised to the power of 5. So this is equals to 2 times, so we have x to the power of 5, so instead we'll write root 2 raised to the power of 5 plus 10 x cubed, so this is root 2 cubed times 1 squared plus x is root 2 times 1 raised to the power of 4. And we simplify it, so this should give us 2. So root 2 raised to the power of 4 is going to give us 4 root 5 plus this is going to give us 20 root 2 plus root 2. So this is equals to 2 times 25 root over 5. 20 root 2 plus oh, I made a mistake. 5c4. 5c4 is 5. It's not 1, it's 5. So this is 5 times root 2. So 5. So this is not 25, but instead this is 29. So this is 29 root 5. So this gives us 58 root over 2. So I think I made a mistake here. Let me cancel this one. This is equals to 2 times 29 root 2. So the final answer is 58 root 2. So this is the answer. Okay. Okay, let's do another one similar to this question. So the next question is, using binomial theorem, we need to prove that root 2 plus 1 raised to the power of 6 plus root 2 minus 1 raised to the power of 6 is 198. Okay, so that's easy peasy. So we know x plus a raised to the power of n plus x minus a raised to the power of n is equals to 2 times nc0 x to the power of n plus nc2 x n minus 2 times a squared plus nc4 x raised to the power of n minus 4 times a to the power of 4 plus dot dot dot. So yeah, so what we're going to do is we're going to replace x by root 2 and a by 1. So that should give us root 2 plus 1 raised to the power of n plus root 2 minus 1 raised to the power of, no, this will be 6. This would be 6. So this is equivalent to 2 times 6c0 x to the power n. So x is root 2. So root 2 to the power of 6 plus 6c2 root 2 raised to the power of 4 times 1. So this is 1 raised squared plus 6c4 root 2 squared times 1 plus 6c6 root 2 raised to the power of 0 times 1. So we get 2 times 6c0 is 1 and square root of 2 raised to the power 6. You can use a calculator, so that would give us 8. So this is simply 1 times 8 plus 6c2. What is 6c2? 6c2 is 15. So 15 and square root of 2 raised to the power of 4 is 4 plus 6c4. So 6c4 is also 15. 15 times 2. Square root of 2 whole square is simply 2 plus 6c6 is 1 and the final one is 1. So that should give us 2 times 8 plus 15 times 4 is 60, 15 times 2 is 30, 30 plus 1. So the final answer is 98, 99, which is equals to 198. That's it. This is proved. So we were able to obtain the given expression. Okay, so let's do one final problem for the day. This is a little bit interesting. So here the question states something like this. So here we have O. This represents the sum of odd terms. The sum of the odd terms of the given expression x plus a raised to the power of n. And we have E. Now E is the sum of even terms. Sum of the even terms of x plus a, the same binomial expression, x plus a raised to the power of n. What we have to do is have to prove. So this is a proving question. We have to prove that o squared minus e squared is equals to x squared minus a squared whole raised to the power of n. So this is our first part. We'll come back to the second part after we solve this one. So let's do this. So let's start with x plus a raised to the power of n. So we know x plus a raised to the power of n is given by nc0 x to the power of n plus nc1 x raised to the power of n minus 1 times a plus nc2 x raised to the power of n minus 2 times x squared plus goes on up to ncn x raised to the power of 0 times a raised to the power of n. Now what we're going to do is we're going to combine all the odd terms together. So this is nc0 x to the power of n plus this nc2 is the third term, which is an odd term, x raised to the power n minus 2 times a squared plus all the subsequent odd terms. We're going to write it together and then we're going to club together all the even terms. So nc1 is the second term, so we're going to club it with nc3, which is x raised to the power of n minus 3 times a cubed and so forth. So this is x plus a raised to the power of n. So this means this is x plus a. We can rewrite it as this is the sum of all the odd terms. So this is simply o plus this is even this is fine, this is odd terms, and the second one is the even terms. So this is what we have done. So we're going to call it equation number 1. Now what we're going to do is we're going to rewrite we are going to write down the expansion of x minus a raised to the power of n, and we're going to do the same thing. We're going to club together the odd and the even parts together. So we know this is nc0 x raised to the power of n minus of nc1 x raised to the power of n minus 1 times a plus nc2 x raised to the power of n minus 2 times a squared minus of nc3 x raised to the power of n minus 3 times a cubed plus dot dot dot. The last term is ncn a raised to the power of n. So what we're going to do is combine the odd terms together. That's the first term, it's raised to the power of n plus nc2 x raised to the power of n minus 2 times a squared plus dot dot dot. So these are all the odd terms. Now what we're going to do is club the even terms. So we see that the even terms are all negative. So what I'm going to do is take the negative common. Then we get nc1 x raised to the power n minus 1 times a plus nc3 x raised to the power of n minus 3 times a squared, and so forth, a cubed, and so forth. So this is x minus a raised to the power of n, and x minus a raised to the power of n is simply equals to o minus e, the sum of odd terms minus the sum of even terms. Let's call it equation number 2. Great. Now what we're going to do, we're going to multiply this first equation to the second equation. So what should we get? So we get x plus a raised to the power of n times x minus a raised to the power of n, taken from the second equation. And similarly, we add the sum of odd terms and the even terms to the subtraction of the even terms from the odd terms. So that should give us x squared minus a squared whole raised to the power of n equals to odd squared minus even squared. Proved. So this was what we were asked to prove. Great. Now continuing on the same note, so the next one is, this was part 1. So part 2, so in part 2, for the same question, for part 2, we are to prove that 4 times the product of odd and even terms is equals to x plus a raised to the power of 2n minus of x minus a raised to the power of 2n. So how do we do that? So all you have to remember is let's start from the left hand side. 4 times the odd terms times the even terms. 4 times. Now what was the odd term? We can always use this identity. If you 4 times o is always equivalent to, we can write it as o plus e whole squared minus of o minus e whole squared. Now this is an identity. This is equivalent to 4 times OE. Why we have done it? Because we have the arithmetic expression for O plus E. So O plus E was simply x plus a raised to the power of n, so whole square. Excuse me. And O minus E is simply x minus a raised to the power of n squared. Then this should give us x plus a raised to the power of 2n minus of x minus a raised to the power of 2n. So this is what we were asked to prove. So this is the term on the right hand side. And the final one
And the final ones where we need to find out. Now find out here is again the proving question. The 2 times o squared plus e squared must be equal to x plus a all raised to the power of 2n plus x minus a all raised to the power of 2n. Okay, so how shall we do it? That's very easy. So we'll start from the right hand side this time. So x plus a raised to the power of 2n plus x minus a raised to the power of 2n. So this can be rewritten as x plus a raised to the power of n whole squared plus x minus a raised to the power of n whole square. If you remember, so this was simply the sum of odd and the even terms. So this is o plus e whole squared, and this is the difference between the odd and even terms. So this will be o minus e whole squared. All we do is simply open it up. So this is o squared plus 2oe plus e squared plus o squared minus 2oe plus e squared. So the OE, the twice of OE gets cancelled out, so what we're left with? Twice of O squared plus E squared. So that is what we are asked to prove. So this is proved because we're getting the left hand side. So we have done a lot of problems today on binomial theorem and like how to expand it. These problems were particularly based on what we covered in lecture number 1, 2 and 3. So you can practice as much as you can, and I hope this was very helpful for you. See you in the next class.